We love the idea of Mars, red sunsets, new cities, humanity becoming multiplanetary. But the reality? It's far more brutal than the headlines suggest. Before a single astronaut launches, Mars needs infrastructure. You don't send people first, you send machines. Cargo missions would go ahead of the crew. Habitats, power systems, life support modules, food supplies, construction robots, and most importantly, fuel production equipment. Why fuel? Because if you don't make return fuel on Mars, you double the mass you need to launch from Earth. That's almost impossible with current rockets. So the first missions would likely deploy ISRU systems, in situ resource utilization plants, designed to turn Martian carbon dioxide and water ice into methane and oxygen. No fuel plant, no way home. Power is next. Solar works, but Mars gets less sunlight than Earth, and dust storms can last weeks. So nuclear microreactors are likely essential for stable, continuous power. Without reliable energy, nothing else functions. Then there's shelter. Forget glass domes. The first habitats will probably be inflatable modules buried under regolith for radiation shielding, or placed inside lava tubes to protect from cosmic rays and micrometeorites. Mars has no magnetic field. Radiation exposure there is dangerous long-term. Shielding isn't optional, it's survival. Now let's talk about the journey. 6 to 9 months in a confined spacecraft. Limited space. Artificial gravity? Probably not in early missions. That means muscle loss, bone density decline, and constant exposure to space radiation. Psychologically, it's just as intense. Communication delays range from 4 to 24 minutes one way. You can't just call home. You send a message and wait. Isolation. Confinement. The same faces every day. No real privacy. Boredom becomes a serious factor. Studies from Antarctic stations and simulated Mars habitats show that monotony and interpersonal tension are major risks. And then you land. Mars gravity is about 38% of Earth's. That affects human physiology long-term. The soil contains perchlorates, toxic chemicals that must be filtered before growing food. Every breath must come from life support systems. Every drop of water must be recycled. Nothing is easy. Financially, estimates for sustained Mars missions range from $100 billion to over $500 billion. That doesn't include long-term settlement costs. You're not just sending astronauts, you're sending an entire supply chain. Food production systems, medical facilities, spare parts, manufacturing equipment, communication relays, backup systems for everything. Redundancy becomes survival. And yet, despite all of this, it's technically possible. Reusable rockets reduce transport costs. Autonomous robotics can pre-assemble infrastructure. AI systems can manage life support and maintenance. The first Mars base won't be a city. It will be a survival outpost. Small crew, buried habitats, constant monitoring, limited mobility. But over time, expand the power grid, expand food production, expand habitation modules. Mars won't be colonized overnight. It will be engineered, slowly, carefully, over decades. Getting to Mars is hard. Getting back is harder. But building something that lasts, that's the true test. If you want a full breakdown of how the first Martian city might evolve, make sure you like and subscribe. Because Mars isn't science fiction anymore, it's engineering.